Hi, everybody. Thanks for stopping by to watch this video today. I appreciate it. It's on the cost approach, accrued depreciation, effective age, and internal consistency, something that a lot of appraisers find interesting and want to know more about. So we're on YouTube. Hit those like and subscribe buttons. What you're going to see later today, I call the Creative Diddling Worksheet, which is available on my website. There's the website on the screen. And we'll get the laser printer going again here. All right, there's the website on the screen. Check it out. There'll be more information on it later. This is a spreadsheet you can use literally for the rest of your professional career. I'm Tim Andersen. I'm here to help. Contact me if you've got any questions. Now, this is what we're going to be working with today. This is just one of the tabs out of the Creative Diddling Worksheet. What we're going to do is we're going to test if that $525,000 is something the market supports. If it doesn't, this will show up and we'll be able to see how and why it doesn't. Now, what we're going to do is we're going to make a couple of assumptions here. We're going to assume that the contract purchase price is $525,000, which is what we're going to take apart via this tab from the worksheet. Now, we're assuming 2,434 square feet at $287.53 a square foot. That's just totally made up. We had to have some numbers in here, but that's just totally made up. We're assuming there's a 532 square foot garage that costs $75 a square foot. And this number is forced, quite frankly. It's just to account for other stuff on the site that we don't account for down here. Now, we've also had to assume $131,250 for a site value. Now, there are ways to extract that. We've discussed that before in other videos, but we're not going to discuss it here. Just assume that you've come up through your necessary analyses $131,250 for the site, as if it were vacant and available to be put to its highest and best use. Now, what this spreadsheet does is this tells us what we have to do to make this number and this number equal. And as you can see, they're over $413,000 apart. So that's what we're going to be taking apart today. And the reason this works is because the sales comparison approach, which is basically right here, granted this is the contract price, but it could just as easily be your value via the sales comparison approach. So we're going to take the sales comparison approach apart using cost approach data to see what we have to do to put in here to make that number and that number equal, which of course does include the site value. The reason we can do this, of course, is that all three approaches to value measure the same things. They measure the value of the site as if it were vacant and available to be put to its highest and best use. And they both measure the contributory value of the improvements. And the reason this is true is simply because there's nothing else to measure in both the cost and the sales comparison approaches. In the income approach too, for that matter, but we're not paying much attention to that here. So here's our question. What is it we have to do to make that number and that number essentially equal? And you'll see what we mean by essentially equal when we get to the bottom of this. So all other things being equal, what we're going to do is we're going to diddle with the accrued depreciation. Now, what we've done is, here we had 0. What we've done here is we've put in 10%. We're just assuming 10% depreciation. We don't know it. We're just assuming it at this point. Now, when we did that, you'll notice that this difference between this number and the number up here you can't see dropped from $413,000 to $334,000. So what this tells us is there's more than 0% depreciation. There's more than 10% depreciation. Now, a footnote, rather than try to allocate this between physical, functional, and external obsolescence, we're using age life, which takes them all into account because it extracts it from the market, and the market does not allocate it. That has to be done mathematically. We're not going to do that. We're just assuming physical, functional, and external because we're using age life depreciation is already in this number. So as you can see, 10% isn't large enough. So let's try 20%. Now, this number keeps getting smaller. This difference keeps getting smaller as we increase the depreciation. We're not changing any of the other numbers we saw earlier. We're just changing the physical depreciation, and that's because of the time limits of the video. So let's go now to 40%. Now, when we get to 40%, you'll notice that that number has gone from over $413,000 to less than $100,000. So by increasing the physical depreciation, or actually the accrued depreciation, as I just explained, we're getting closer to explaining if that $525,000 is really accurate. Now, obviously, I've done the math, but when you put in 52.2%, what you find is this number and the 525 are essentially the same. They're only $33 apart. So we're not going to get excited about $33,000 when we're talking about over $525,000, or excuse me, almost $525,000. So what this is telling us is that when we apply 52.2% accrued depreciation, we bring the cost approach and the market value or the contract price or whatever price it is you're trying to test into parity. Now, you say, wait a minute, Tim, all we did here was guess. Yeah, that's all we did. We guessed. But we went through a series of guesses, and we don't call them guesses. We call them iterations. We went through a series of iterations to find out how much depreciation it was necessary to take to get the sales comparison approach, or the contract purchase price, into parity with the cost approach. We use the cost approach to take the sales comparison approach apart. That's why this works, because they measure the same things. They measure the value of the site as if it were vacant and available to be put to its highest and best use, and they value the contributory value of the improvements. Remember, a site has value. Improvements contribute value to the site. So we got them essentially the same. Now, could we go even further down with this number? Could we try 52.21%? Yeah, we could, but we're $33 apart. So, who cares? It's no big deal. So what we're going to do now is we're going to worry about effective age. Now, when we started this video, we spoke about extracting effective age, and that's exactly what we're going to do as this video progresses. Now, this is a view of the entire site, the entire spreadsheet that we were looking at. We got the $525,000 into parity. Again, this could be your value via the sales comparison approach, the contract purchase price, whatever. We got it into parity with the cost approach by going through all of these calculations here, specifically that one. Now, somebody's going to say, where did you come up with $15,000? That's a guess, as it is typically in any residential real estate appraisal. So don't lose a lot of sleep over that. But anyway, we've got them into parity. They're only $33 apart, so really, who cares? Now, what we're going to do is we're going to continue to test that $525,000 relative to that $525,000 to see if we can extract the effective age of the property. Now, just so you'll know, yes, there is some circular reasoning going on here. This circular reasoning is that we're assuming the target number is correct. So far, I haven't shown you how to take it apart even further to see if it is correct, but that's where we're going. And the purpose, again, of this spreadsheet is to diddle with the numbers until they work, until you get parity, like we just did. Then we're going to test to see if that makes sense, which is where we're going. Now, it's the diddling that forms the iterations. Yes, we're guessing, but we don't call them guesses. We call them iterations. We're looking at the data. We're changing one variable to see what happens to the rest of the data. You could call it a sensitivity analysis, and that's the key. The iterations are the analyses, and USPAP many times uses the word analysis or analyze in order to encourage appraisers to understand what's going on in the market relative to the comparable sales as well as the subject. Now, it's okay to guess. In other words, it's okay to enter a number of iterations just to see where they lead you. And as we just saw, they led us to an indication of what it took for the sales comparison approach or the contract price to equal the cost approach total. We got them both to about $525,000. It's also totally scientific to take a set of numbers, a set of parameters, a set of variables, and change one at a time to see what it does to the rest of the data. That's why it's called a sensitivity analysis, and that's exactly what we have done. So via the iterations, we scientifically are in the position to take apart the data to see what the data tell us. It's that taking apart of the data that is the analysis. And what we've done is nothing more than extract the answer to the question. In other words, is can we get to $525,000 from both the sales comparison and the cost approaches, which is what that spreadsheet shows. We got down to $525,000. Now we're going to take a look at this part right here to see if that's reasonable. Now, what you see at the bottom of the page is from the 15th edition of the Appraisal of Real Estate. I didn't write it. This is not my original thought. This is taken from the 15th edition. It happens to be page 571. This is the mathematical formula for calculating effective age. Now, it's set up to calculate depreciation. So the effective age divided by the total economic life is depreciation. Now, this is set up to give a dollar amount of depreciation. If you leave this part out, you get a percent depreciation, which is what we're looking for. Because there is a mathematical relationship between effective age, total economic life, and depreciation, we can work this formula in the opposite direction to isolate effective age, which is just what we're going to do. So we start with depreciation, which again, via iteration, we got it 52.2%. And then we multiply it, because this is division here to undo it. We multiply depreciation by total economic life, and we get effective age. Now, we've got to go back to the spreadsheet to show how this works, because we're not done with the analysis yet. Now we're back to the spreadsheet. Here's that quote. again, what we're going to do is we're going to start with depreciation, which is at 52.2%. And then we're going to multiply it by total economic life to see what the effective age is. So just follow along here. And we've got this up so you can see the quote. Take a screenshot of it. Go ahead. That's perfectly fine. But this is the mathematical relationship. Now, again, you notice this just says depreciation. Via this method, you can't allocate accrued depreciation to physical, functional, and external. You just get one number. So to take accrued depreciation apart into its components is difficult, and we're not going there. And for the typical residential real estate appraisal, you don't need to go there, so don't worry about it. Now, what we've got here is what we're going to try to do is we're going to mess with these numbers. We're going to diddle with these numbers until depreciation, the stuff in yellow, is equal to the stuff in green. Watch. We're assuming a total economic life of 70 years. This is a pretty good house. Okay, give it a longer than typical lifespan. If you think it should be 65 years, okay, put in 65. If you think it should be 60, put in 60. That's part of the diddling process. For simplicity's sake, I put it in at 70%. Now, what we're going to do is we are going to get this, which is that number, which is just transferred down there, equal to that by diddling with remaining economic life so that we get the indicated percent depreciation in green and the percent depreciation in yellow to be the same number. So follow along. And what we're going to do at this point is we're going to diddle with this number. Let's go back here. We changed it to 15. Well, we left the 70. We put in the 15, but the yellow and the green still are not equal. So let's keep diddling. We're going to change the 15 to 25. All right. By increasing the remaining economic life, this was 70-something%, but now it's 64%, which is a whole lot closer to 52%. Therefore, by increasing this number incrementally, we're going in the right direction. So let's increase it to, the answer happens to be 33.46 years. But by increasing this number, we didn't change the 70%, or excuse me, the 70 years. By increasing this number, we got this depreciation, this one up here, and this depreciation percentage to be equal. That's what we're going for. This is the proof. And this is the proof that these numbers are right. Now, we're not quite to the bottom yet. But what we've done is, via the mathematical formula, which is that one right there, we took depreciation, which we knew, and we multiplied it by economic life, which was a guess, but it's really an educated guess. It's going to be between 60 and 70 years. And we came up with effective age. So this is mathematics. Okay. You can't argue with mathematics. You can argue with the stuff that goes into the formula, but you can't argue with the mathematics. This indicates the subject is effectively 35, 36, 37 years old, however you'd want to round that. Now you say, Tim, that's wonderful. So what? Remember on the first page of the URAR form where you have to put the effective age? Don't until you've done this analysis. And when you've done this analysis, and you're going to do it 4 or 5 times, then you come up with an effective age from the market, not from what you hope to be correct. Now remember, standard rule 1-3, B, the comment, specifically says, appraiser, please don't make any funky assumptions about total economic life or effective age. This way, you don't have to. You have extracted it from the market. Now, let's take a look at this 50% up here, or 52% up here. What we're saying is that reasonable? Now, if your house is 5 years old and it's 52% depreciated, you got some serious problems. Probably something very funky, like 5 bedrooms and 1 bathroom, period. Or there is a monumental external obsolescence factor. And let's face it, right now, and I'm recording this in March of 2023, we are operating under an external obsolescence factor, and that is the fact that in a year, interest rates have increased over 100%. They were approximately 3% a year ago. They're a shade over 7% now as we record this. That's an external obsolescence factor because that is going to lower prices. In other words, if you've got $2,000 a month to spend on your mortgage payment, then you get more house at 2% than you do at 7%. That's the external obsolescence factor. So you look at this number, is it reasonable? Now, if the house is 20, 25, 30 years old, yeah, it's probably reasonable. If the house is 100 years old, unless it has been significantly renovated over the years, in other words, walls have been moved to make rooms larger, the bedrooms now have walk-in closets rather than armoires, etc. The electrical has been totally upgraded to modern. Then if you've got a 100-year-old house, but it's only 50% depreciated, that means it depreciates at 0.5% a year, which means it has a total economic life of 200 years. And yeah, the house will probably stand for 200 years, but total economic life is not how long the house is going to stand. Total economic life is how long is the market going to demand that house. And unless 200-year-old houses have been significantly renovated, repaired, etc. over the years, the market doesn't demand them. So you look at this for its reasonability. If you think it's reasonable, go with it. If you don't, do some more diddling until you get to where it is reasonable. You don't like 70 years, put 65, and then do some more diddling to get this all to balance. The issue is, as you diddle, that number in yellow and that number in green have to be essentially the same. This is 52.2. If that came to 52.23, who cares? But the point is, this is how you extract effective age from the market, not from guessing, not from that sheet of paper your first supervisor gave you 25 years ago. This is how you extract it from the market. It's by this iterative process that we extract effective age from the relevant market data. So how does this iterative process help us, the boots on the ground appraiser, to come up with more credible value opinions, more reliable value opinions, etc.? We use the mathematical relationship between accrued depreciation and total economic life to extract, whoops, there's an error that I can't fix now that I'm recording this, to extract effective age. Sorry about that. So you're going to watch, you just seen me make a mistake. I apologize to you for that. So there's no guessing, there are no estimates, there's no boilerplate. It's just market data. And because of all this stuff, there is no bias. And that's what we're trying to avoid, bias. We go through all of this. We go through the iterations to make sure that we have not arrived at a value conclusion in a biased manner. And when all we're using is the market data, and when we're playing with the market data to see what it tells us, when we're going through these iterations, we avoid bias. When we avoid bias, we're internally consistent. Let me tell you what I mean. If you put, in this case, we had 52% accrued depreciation. If the appraiser were to have put the property, put on the first page, the property was effectively 20 years old, then the appraiser has to support a guess. Whereas if the appraiser does this work first to isolate effective age, then go back on page 1 and put what goes in there, then the appraiser has done that from the market. There's no bias involved. There's no guessing involved. And it's not hard to take the concept of a guess and turn it into bias. And how is that done? Simple. The guess supports the appraiser. It doesn't reflect the market. That's the bias in it. Now, this is a quick recap. If you see something, you want to save it in your work file, absolutely without question. Keep every iteration of the analyses in the work file. Now, this is a paper work file for illustration purposes. If you've got this all on the cloud or all on an auxiliary drive someplace, fine. I'm just using the paper for the example here. You keep every filter you applied to the data in the work file. In other words, if you said, if your first go around with MLS was give me all of the 3 2s, those are filters. Then the next go around was, okay, give me all of the 3 2s with a 2-car garage. There's another filter. Okay, all of the 3 2s with a 2-car garage on a site of less than 10,000 square feet. There's another filter. You keep all of those in the work file. You keep a log of every phone call you make in the work file. Calling the zoning office to find out what the zoning is, calling a broker to verify a sale, etc. Every email you send or receive on this property, you log in the work file. That way it doesn't get deleted from somebody's queue. A peer appraiser, in other words, somebody who has your training, your experience in a particular market, etc., should be able to take your work file, your big, thick, fat, nasty work file, and replicate from the stuff that's in it every conclusion you reached, every opinion you formed, etc. That's why we go through all of these iterations. So all of that information is there. Now, this says peer appraiser. You could also put state investigator, because that's basically what the state investigator is going to do. Look to replicate from the stuff in your work file every conclusion you reached, every opinion you formed, etc. So a thick work file is the appraiser's best friend. Now, if you want a copy of what I call the Creative Diddling Worksheet, go to my website, theappraisersadvocate.com, go to Products, go to Creative Diddling Worksheet, which has more applications than this. I'll be happy to explain it to you. It's $29.95. It's a one-time charge, and you can use it forever. And if you have any questions, get in touch with me at tim@theappraisersadvocate.com, and I'll be happy to answer them for you. So let me thank you for watching this video. Let me thank you for hitting those like and subscribe buttons. Please get in touch with me if you've got any questions, and we will see you on the next video. Thank you.